Welcome, everybody. Thank you for being with us today. My name is John Bagnulo, and I'm covering a topic this afternoon, which is one that I'm very passionate about, not only because of how it influences human health and so many different populations around the world, but also how it obviously affects the environment, water quality, soil quality, and the future capacity of not only the United States, but the rest of the world to feed a growing population. And this is really on organic agriculture. Today's topic will look at how it is we can choose foods organically grown more effectively, prioritizing some of those choices, and what are some of the consequences for consuming larger amounts of non-organic or conventionally raised produce. So this is this is science-based talk. I'll have references for any of the papers that we discuss, and it's one that we are again hoping to offer CEUs for this. But just as a brief FYI, that approval process is still pending. We fully anticipate to be able to offer these CEUs, and we'll certainly let you know as soon as that is approved. So with that being said, let's first take a look at what it is we hope to accomplish this afternoon. Number one, it would be very important for participants to identify those agrochemicals that are commonly used, where they're found, and what the risks are to human health. Prioritizing the choices that we make for the populations that we work with or for our own self, it's very important, and we'll have some research which will show where it's most important to purchase and rely on organic vegetables as well as fruit. And we'll also really dive into and explain how it is some of these chemicals alter human physiology, either through the microbiome or a direct influence on the neuroendocrine system. These are a list. We're not going to be able to cover all of these pesticides and or herbicides because of just the complexity of each, but these are the most commonly consumed pesticides here in the United States. And those with the asterisk next to them are, interestingly, are banned in Europe and in other countries. And there's a growing gap between pesticides that are banned in Europe and in other countries and those which are not here in the United States. And in that, with my public health degree, and in reviewing, assessing all of the scientific literature on the health effects and or environmental influences that many of these chemicals have, it's very difficult for me to explain in why the United States has not followed the path or suit with respect to Europe and in many Asian and South American countries. But that be the case as it is now, we will move forward into this and take a look at just general consumption patterns of fruits and vegetables with higher levels of pesticides and or herbicides and those with lower. One of the influences on human health, which is most clearly understood and appreciated, is the influence that high pesticide level fruits and vegetables, and we'll get to those in a moment, what are the influences that has on reproductive health? And we know unequivocally that the consumption of larger amounts of high pesticide residue fruits and vegetables is associated with much greater pregnancy losses at different phases during pregnancy, different trimesters, but unequivocally, there is a much greater risk for pregnancy loss with increased consumption of pesticides collectively. Now, again, this is a paper that was published in JAMA. It's a little over 2 years old, and it looked at total pregnancy loss as well as what happened when mothers were able to replace the highest tier pesticide fruits and vegetables with a equivocal serving of low pesticide fruits and vegetables, whether those would be organic or they were conventional but falling in the lowest pesticide residue category. You can see that there was a much greater likelihood of implantation and having a live birth and having successful overall pregnancies, and much lower risks, again, to emphasize what was demonstrated in the previous slide, much lower risk of pregnancy loss. So these are, again, these are very important observations that are well appreciated and understood across the scientific community. And as we dive into some of the more harmful and influential pesticides and herbicides, at the top of that list, by most toxicologists' perspectives, would be chlorpyrifos. And chlorpyrifos is has been well studied now for over a decade, and especially how it influences pediatric health. Now, this is, again, as is the case with many of these pesticides, it can be applied by hand with something as simple as a backpack sprayer. It can be applied with a crop duster, whether that be a helicopter or a plane, over larger areas. But chlorpyrifos is, to date, one of the more damaging organophosphate pesticides to the neurological system in humans. And this is a paper which is, again, it's 8 years old. This is not a recent headline, but it showed how there were significant changes in brain areas of the brain anatomically, as well as how you had firing patterns, neurological recruitment in other areas, but within the neurological system. So there were these abnormalities that were being observed initially in adults and then later on in pediatric populations with higher levels of chlorpyrifos residues in the urine and in the blood. And so researchers were able to draw this very distinct relationship between dietary chlorpyrifos through fruit and vegetable consumption. Again, those fruits and vegetables with the higher levels of chlorpyrifos, they found that there were correlating levels of chlorpyrifos in the blood as well as in the urine and some of the metabolites when these populations were attempting to detoxify them. And the higher levels that were detected were associated with greater and greater levels of these brain abnormalities. Now, in the most recent study looking at this, the effects of this, it was shown that the children at age 3 with the highest levels of both prenatal and early childhood chlorpyrifos exposure, they had major delays in their developmental scores at age 3, and that you started to see some of the separation between higher levels of chlorpyrifos exposure and lower levels at age 2. So as little as 24 months, researchers were able to find amongst this roughly 254 children that were followed for 3 years, they were starting to detect these developmental influences, neurological development, cognitive impairment. So, it's really clear that exposure to, in this one specific pesticide, chlorpyrifos, it has very deleterious or harmful effects on both pediatric and adult brain health and development. And it's widely found in all ages across the United States. And we'll get to those leading sources in a moment, but it's very important to help all of you understand today how it is that we are given, or agricultural guidelines are determined. How are they established? And it's really established on what are called average expected intakes. Okay, so the EPA, the FDA, the USDA, all of these organizations really rely on average estimated intakes. How much of a certain pesticide would be consumed if specific age groups consumed X number of pounds of any given fruit or vegetable per day. And what we've seen is that the target risk level established earlier with respect to chlorpyrifos in particular is a fraction of how much is actually being consumed. So the actual chlorpyrifos consumption in the United States is in most cases 10 times greater or more, and sometimes you can have significantly larger intakes than what was an estimated intake established, again, a much longer period of time. 2 decades ago is when some of these levels were established in terms of expected intakes, but the greater and greater use of chlorpyrifos and its appearance are being detected now in a wide variety of foods, which it was not originally intended to be used for, has left us with this really stark contrast between what is actually being consumed and what was an expected level of consumption now more than 20 years ago. Very different. We know that when you look at the amount of chlorpyrifos and its metabolites that are being detected in the urine of subjects, and we've got roughly 500 subjects in this one particular study that was done through the state of Washington in their environmental department. What we know is that folks that are eating organic fruits and vegetables, they have markedly less of the chlorpyrifos in their urine than those who are largely eating conventional foods. And the more any population eats organic foods, then the lower the levels of these chlorpyrifos metabolites being detected is found. So it's axiomatic. If you eat less of the conventional and the most chlorpyrifos contaminated foods, you will have less of this in every compartment in the body. Now, it's important that I say this because one of the criticisms that I have frequently heard, and I would say these are, again, a minority. Most of the toxicologists and environmental scientists that I speak with and whose papers I look at are collectively in agreement that this particular pesticide, chlorpyrifos, is a direct relationship to the levels of fruit and vegetables consumed where chlorpyrifos is part of the standard treatment during the growing season. So again, I think most of us could understand that if you're eating organic fruits and vegetables, you're going to receive significantly less of a toxic burden on the human body. And it is not something that you're going to simply get by breathing the air, drinking the water. It is a function of how foods are grown. And you can see the good news is 3 days of conventional diet, high levels of this chlorpyrifos in the urine. But when any age goes with organic choices for 5 days, those levels drop by more than 75%. So, this is what's really important, that there is a message here where the damage, the toxic burden can be reduced by making a change to better foods, more organic produce, especially for the most pesticide-laden choices. Now, chlorpyrifos is, in addition to causing brain abnormalities, both anatomical as well as in the way the brain functions, it also has a very significant influence on the microbiome or our microbiota. And whenever the microbiota is influenced and we have a damage to important families of bacteria and an overrepresentation or an overgrowth of potentially pathogenic bacteria, almost without exception, we have changes in any population study, whether it's pediatric or adult, whether it's those with diabetes or without. You almost always see a change in inflammatory markers as well as insulin sensitivity. And there is no exception here with respect to this organophosphate. And I just, when I say organophosphate as a category of pesticides, they are typically the most damaging. Many of these are not only neurotoxins, but to the point of these next few slides, they also are highly damaging to sensitive families of bacteria. And so what has been observed with this paper that's little less than a year old now is that chlorpyrifos consumption causes insulin resistance directly through the loss of important families of bacteria, which we can get to a little later on. We covered some of these in previous webinars, families such as Akkermansia, Bifidobacter. These are highly influential on insulin sensitivity. They tend to produce lower HOMA-IR scores. That's a homeostatic metabolic assessment tool, and it's simply a function of fasting insulin and fasting glucose. And It really reflects how effective insulin is at reducing one's glucose levels, serum glucose levels. And we know that, again, and that's the case here with chlorpyrifos, that this pesticide causes higher HOMA-IR scores and higher levels of plasma lipopolysaccharides. That's what you see here. That's the third. That's representative by the bar graph here, C. You will see that regardless of whether it was a high fat or a low fat diet, and the researchers have to have different types of dietary models in place to control for the potential confounding influence that the macronutrient composition is influencing something like lipopolysaccharides in the blood, or gut wall permeability, or, again, as we've been talking about, insulin sensitivity. In both cases, whether it's a high fat diet or a low fat diet, you'll see that the addition of chlorpyrifos to the diet at levels similar to what humans get, and this has been replicated with the human model, but with an animal model, there are higher levels of lipopolysaccharides entering the bloodstream, which means gut wall permeability was altered. In addition to that, you can see that there were significantly higher HOMA-IR scores, higher levels of insulin, as well as fasting glucose. So, everything within the microbiome starts to take a turn for the worse with these small chronic exposures provided to the body through high pesticide residue fruits and vegetables. So there's, again, there's different components to this, but all organ systems, the liver, the brain, the microbiota, all are influenced by the presence of this pesticide in small chronic doses. And I have to emphasize that, because that's really what is often underappreciated in the field of epidemiology. There is a chronic exposure influence to many of these agrichemicals that may not be captured in a 2-week trial. But when trials are taken out for long enough periods of time, that's when we really start to see how harmful the influences are on different organ systems. Now, shifting gears, we're going to talk about an equally damaging agrochemical, one that has been applied to crops at an unprecedented level. Never before in human history has any agrochemical been applied to the food we eat at the rate with which glyphosate has. And again, for those of you who might not be familiar with glyphosate, but might know its brand name is Roundup. Roundup is used on lawns. It's used in so many different applications in an effort to suppress weeds, eliminate weeds from a crop or any particular agricultural system. And glyphosate is being found now through, it doesn't matter whose research you look at, whether it be through a university's attempt to quantify this with our food supply. You could look at the research that's come out of the Canadian government. You can look at, these next 2 slides come from Moms Across America, which is it's a nonprofit organization which always attempts to reflect where the highest risk is for our children in the United States. So Moms Across America, a few years back, funded the testing to look at a wide variety of foods, common foods. And again, it's not to pick on any one of these, but these are just commonly consumed foods by families and children in particular, from all walks of life. And you can see that the levels range, but are all extremely high, especially in foods which rely on oats as a big ingredient. Oats tend to be one of the biggest carriers, one of the largest sources of glyphosate. And you can see that's why you'll see some of these breakfast cereals have exceedingly high levels, but they're found in other foods. And you can see that even, you can find some foods that, whether it's a soy ingredient or it's a wheat ingredient or barley, there are a wide variety of choices here to look at as high residue or high glyphosate residue foods. So this was from Moms Across America, and the environmental working group independently and very recently looked at 28 different breakfast samples, and they found When I say they, the environmental working group, whose symbol is, that's what you see in the lower right-hand corner of the slide, in that green triangle, that's the symbol for the environmental working group. They have a very well-respected panel of environmental scientists and toxicologists that are familiar with the different ways that some of these chemicals influence human health and where they're found. And they put together this panel, and they looked at these 28 different breakfast samples, and they found that all 28 contained glyphosate at significant levels. 26 exceeded the 160 micrograms that was used as a lower level of detectability. Now that's a very, very high level when you can appreciate what has been shown with glyphosate. We're going to get to that in a moment. And this is really where glyphosate would be found on a nutrition facts panel for two very commonly consumed breakfast cereal. You can see there would be more glyphosate than there would be vitamin D. For the top one, it'd be just behind some of the other micronutrients which it is fortified with. So again, when you get into these, again, parts per million, we're in the thousands of micrograms here per kilogram of a food. That's incredible when you take into account what has been demonstrated with glyphosate and its influence on very important families of bacteria within the microbiome. Those influences go down to 0.1 parts per billion. Now that's a very difficult level of exposure for any of us to appreciate. And it speaks to how sensitive bacteria are to this chemical, which was developed really to disrupt a plant or a bacteria's ability to produce critical substances for its survival. So that's why it's so that's why it's so influential on certain families of bacteria, as well as on weeds and plants. It really has to do with how it undermines their ability to endogenously produce the antioxidants that allow them to survive in sunlight or allow them to compete with other plants or insects. And you know, those molecules, unfortunately, are antioxidants. So glyphosate, in addition to being toxic and causing issues within the microbiome, and you can see that the levels that are allowed in, that have been detected through the Moms Across America research, as well as what's been found in so much of the U.S. water supply, as well as in things like oats and soybeans, where you have these Roundup ready crops, which can be sprayed with very, very high levels of glyphosate, thereby killing all of the other weeds, but allowing the crop to survive. That's why we're ending up with these unprecedented levels. And they're much, much higher than what glyphosate was originally approved for back in the early 1990s. It was approved for very modest applications, once or twice a growing season as a selective herbicide, but that's not the case now. Now it is really, you know, used at 9 to 10 times the levels that it was originally approved for, and that's one of many reasons why we're finding such higher levels. And Monica Kruger, who is a well-respected toxicologist, done a lot of work again with the epidemiological influences of various agrichemicals. She's found that when we look at the glyphosate levels in adults, you typically find much, much higher levels in those that are chronically ill. Now, again, that's an association. That's not a cause and effect. But once you start to draw multiple associations, and you start to look at some of the Pearson correlation coefficients, which describe the strength of these associations, you know, it becomes much easier for us to start to connect the dots between dietary exposure to many of these agrochemicals and the increased risk. Now, again, browning is why we now have such higher levels of glyphosate use. As I mentioned just a moment ago, when glyphosate was originally approved, it was a selective herbicide used once or twice during the growing season. And now it is used to brown crops in the field, which is called crop desiccation, sometimes referred to as browning. What that does is it effectively dries a plant or a field of a plant or a crop, and it dries it in the field and essentially prepares it for harvest with a much lower weight, much easier for large scale agriculture to go through, and in 1 or 2 passes, essentially gather all of that crop material to bring it in to be sifted, sorted, for the edible component. But the problem with this is the browning requires glyphosate to be used at, again, these massive quantities. And that's yet another reason why we're ending up with so much of this in our bodies, and especially in our children's bodies. So it's important to understand that. And the shikimate pathway, which I've referenced, that is how glyphosate works. It blocks the ability of plants, certain plants and bacteria, to produce what we call aromatic amino acids. Those are the ones you see at the bottom of the slide. Tryptophan, everybody identifies that as an amino acid. It's an aromatic amino acid. It has what's called a benzene ring attached to it, and it's used to produce so many important substances, not only in the human body, but also in plants and in bacteria. And that's the same with phenylalanine and tyrosine. So once an herbicide like glyphosate is used, and a plant, or as we're going to talk about in a moment, a bacteria can no longer produce these essential amino acids, then the plant will die. And that's really what's going on here. That's its primary mechanism as an herbicide. But what people have failed to appreciate is that, number one, many of those aromatic amino acids like phenylalanine and tryptophan, they are needed by plants to produce, you can see that on this slide, flavonoids and anthocyanins and antioxidants. Really, and I'm going to speak to this again in a moment, one of the primary reasons we all do better when we eat more vegetables and fruit is that we consume more of these polyphenolic substances, which are ringed aromatic amino acid based antioxidants. And these polyphenols are why we get so much added protection, as well as the fiber content from vegetables, and to a lesser extent from fruit. But certainly fruit contain some of this fermentable fiber, and they can certainly be a great source of antioxidants. But that's the primary mechanism with which vegetables and fruit protect us. So why would we want to grow vegetables and fruits with an agricultural system or model that reduces their production of antioxidants? I think that's really the multi-million-dollar question, the question that everybody that is involved with agriculture should be asking themselves. Do we want to grow crops which actually contain the antioxidants known to be the most protective quality of a plant-based or vegetable-based diet? Or do we want to grow crops which have significantly lower levels of these, and at the same time we're adding glyphosate residues and other pesticide residues which carry their own known risks? I think it's a very simple question to answer. I just don't think, unfortunately, I don't think enough consumers, healthcare providers, and those that are providing guidance on what we eat and what's safe to eat, I don't think it's a question that enough are familiar with. But I think that should be a major public health initiative for all of us involved in the public health arena to start asking. And this slide really shows how those antioxidants are compromised once you have an absence or an inability for a plant to produce a specific amino acid. So that's important. Again, everything always comes back to the microbiome, or at least it always seems that way. It is the most intensively studied and researched area right now in science. That is, how do microbes control our health? And everybody agrees now that microbes have far greater control over human health than our genes do. It's always important to say that and to appreciate that. And then once you start to understand what are those factors in our life that have the greatest influence on the microbiome, it becomes easy to see how we can either shortchange and compromise our microbiome, or how we can foster it and develop it in a much healthier way. And that's the case with glyphosate. Glyphosate exposure tends to eliminate some of the most important bacteria, which we call commensal or beneficial bacteria, such as the bifidobacter family, which are, again, these are N-butyrate producers, highly anti-inflammatory. In every study ever conducted on bifidobacter, it's unequivocally been demonstrated. The more bifidobacter we contain in our microbiome, the lower our risk for most chronic diseases, the better off we are, the less inflammation we'll be under. And it's the same with Fecalibacter prusnitzii and certain lactobacilli strains, but to a lesser extent. Now, the flip side of that is that we have families of bacteria, especially the Clostridia family, which we want to have markedly lower levels of. Now, everyone's familiar with C. difficile, but that's just one representative. There are a multitude of Clostridia members, family members, and almost all of them carry with them, when you have higher levels of them, the production of, or the risk factor for these endogenously produced, because they're produced within the microbiome by this Clostridia family, these metabolites that reach the brain and the neurological system by and large, and have very damaging effects on the mitochondria within our neurons. So when we talk about glyphosate exposure, and you can look at some of the work that's put out by, whether it's Nancy Swanson, looking at NIH, CDC statistics, and looking at the relationship to glyphosate exposure, primarily through corn and soy-based foods, the consumption of those foods, the glyphosate level.
John, your sound just cut out. If you can try coming back.
You see that there are strong associations found between glyphosate exposure and autism. Again, not demonstrating cause and effect, but then on the other side of the slide, and this is a wonderful paper in the Journal of Integrative Medicine by William Shaw, you can see that glyphosate, in addition to eliminating those really beneficial bacteria, it tends to promote the growth of Clostridia, which are very resistant to glyphosate. And that's where you end up with some of these metabolites that are damaging to the mitochondria. One of those would be, a very simple understanding would be propionic acid. N-butyrate or butyric acid is really what we're looking for a short chain fatty acid being produced by gut microbes. And that's produced by bifidobacter and some of those other families like Roseburia. But when you get to Clostridia, it's not producing N-butyrate, and higher levels of propionic acid have always been shown to be a greater risk factor for not only autism, but other neurological conditions and neurodegenerative issues. So again, the gut microbiome brain axis is well established, becoming increasingly understood. And it's important to note that the metabolites produced by the bacteria, whose populations are favored with chronic glyphosate exposure, that gut brain axis, in particular, how the microbiome generates specific metabolites that can influence mitochondrial health, neurotransmitter production, that there is a link now, a link that connects glyphosate exposure to dysbiosis or imbalances within the microbiome. And then there are clearly higher risks for many neurological conditions with these patterns of gut dysbiosis that are produced by chronic glyphosate exposure. It's important to appreciate that as one of the most well-established mechanisms with respect to glyphosate. I am not sure. I have no empirical evidence that glyphosate causes cancer with chronic low-level exposure. And I want to be really clear in saying that. I have no empirical evidence of that, but I do have empirical evidence that glyphosate exposure disrupts the microbiome and leads to issues that are secondary to what we call dysbiosis. So I just want to make sure that everyone understands what I am saying scientifically and what's supported, two very different things. Now, Here's where things get really interesting, especially when you talk about the connections between our epithelial cells, which are often referred to as tight junctions. We know that dysbiosis compromises those, and there are a variety of dietary constituents that further compromise those, such as a fructose-rich diet, made up of lots of fruit juice and fruit purees and things along those lines. Fructose is very damaging to the microbiome, causes dysbiosis, and secondary to that, we're going to end up with this kind of increased intestinal permeability. Omega-6 rich seed oils tend to do the same thing. But when you add chronic glyphosate exposure to that as well, and a disruption of that Shikimate pathway, which we've talked about, that's when you get the Clostridium overgrowth, the higher levels of propionic acid. And that's when things really take a 90-degree turn and go sideways with respect to ability to detoxify and the burden that is placed on systemic circulation with some of these compounds because of increased intestinal permeability. So the point I'm making with this slide is that glyphosate exposure put on top of an otherwise already imbalanced diet with high levels of dietary fructose and high levels of omega-6 rich seed oils and some of the wrong proteins like A1 casein and maybe gliadin for those that are more gliadin or gluten sensitive, you really end up with a perfect storm. And glyphosate puts many, both children and adults, over the proverbial cliff, so to speak. And now all of this damages the mitochondria. And that's, once you have increased intestinal permeability and overwhelmed detoxification capacity, you're going to have mitochondria suffering at this front and center. Now, again, there's so much research that's come out of not only the Environmental Working Group or Moms Across America, but other institutions and organizations across the world. Some of these are in Europe, in Italy in particular. They're finding that glyphosate levels are high across the globe. Many of these are significantly higher than what's allowed in drinking water supplies, both here in the US as well as in Europe, and then across the board. Those with the higher levels of exposure, there's a linear relationship here, have the greatest levels of dysbiosis within the microbiome. The good news, and I think it's always important to try to find a place here of hope and possibility, is that once glyphosate exposure is reduced through choosing organic fruits and vegetables, you're going to see in a very, very rapid response time markedly lower levels of glyphosate in both the blood as well as in the urine. This is a paper which was just released this month looking at organic interventions, organic dietary interventions, and how those influenced both circulating and urinary levels of glyphosate. Very hopeful, very promising results in this very new publication. And I think it, should provide, again, just one more piece of evidence or part of the thought process or rationale for folks to make important shifts towards organic vegetables, especially in the worst case vegetables. So, yeah, it's really clear. We can reduce our exposure. We're going to have certain choices that are going to be much more important to make than others, and that's where I like to recommend the Environmental Working Group's well-known, well-publicized, and appreciated guide. It's done quarterly, so every 3 months, the Environmental Working Group will gather through their research. Collectively, they work with other organizations like the USDA and the EPA, and they collect as much data as they can on the pesticide and herbicide, as well as fungicide, which is, fungicides are used to control mold and fungal growth on fruits and vegetables, as well as on grains and cereals. So the Environmental Working Group every 3 months is compiling data, and it's coming up with their Dirty Dozen list. And you can see this is the most recent Dirty Dozen list, and strawberries are almost always at the top. Some of that has to do with the use of methyl bromide, which was supposed to be banned over 14 years ago, but now every year, strawberry farmers in California are allowed to file an extension to continue using methyl bromide. It's one of the most powerful neurotoxins ever used in agriculture, and strawberries contain it, and they contain bromide as a result. Bromide's, of course, not good for our endocrine system or a thyroid. So that's one of the worst. And you see spinach is a close second, kale, nectarines, and so on. Peaches, very high. They're usually in the top 4. In this particular one, they're 7th. So this is a very important guide for consumers as well as clinicians that may have suspicions around a patient's particular pattern of health or conditions, and how that may be a result of some of their food choices, especially the high residue, high pesticide residue choices. Now this, again, this is the dirty dozen, and this is the clean 15. You can see avocados are almost always at the top. Onions are there as well. Broccoli is usually in the top 10. And these are those vegetables and fruits which tend to have the lowest levels of pesticides and other agrochemicals. And again, measured every 3 months. This is updated. The environmental working group, you can go to their website and you can print out a wallet or pocket-sized guide on this, which is, I think, a great resource for any of you interested in maybe, making this application part of your daily life. So far, we've discussed the high risk component to eating vegetables and fruits which are produced with certain agrochemicals. But I've touched on this earlier. I want all of us to really appreciate the most protective aspect of fruits and vegetables, and that's their polyphenolic content, which really drives their antioxidant ability. It's what I spent a significant part of my PhD work looking at. My research looked at blueberries and how blueberries were protective against a variety of conditions or issues within the area of women's health. And we know that it's not just blueberries. It's, of course, all of your berries, whether it's, cranberries, blackberries, as well as other members of the kind of small berry-like fruit world. Coffee fruits or coffee beans are certainly the same. And all of these high polyphenolic substances offer protection as long as the plant is allowed to have a normal Shikimate pathway in its production of antioxidants. And that's why when we look at vegetables and fruit with the greatest polyphenolic content and those which are produced organically versus those produced conventionally, this 2014 paper in the British Journal of Nutrition, the primary investigator is Baranski. It's a meta-analysis, and it's really looking at fruit and vegetable samples from the previous 20 years with good study design, meaning you had a large number of samples, there was good quality control in place. This meta-analysis showed that there is a clear relationship to the polyphenolic content in organic fruits and vegetables being higher antioxidant values than in those produced conventionally. And it's all explained by the role that some of these pesticides and herbicides play in disrupting a plant's natural ability or requirements to generate some of these polyphenols and antioxidants. So again, this Baranski paper is a really good one to look at. You can see that it's comprehensive. It's looking at so many different substances which we know offer benefit to specific vegetables and fruit. The mineral content might be the same. The amount of calcium in spinach grown organic and conventionally will be the same. That's because it's more a function of the soil conditions and what's available in the soil. But when it comes to polyphenols and antioxidants and some of those really powerful mitigators of disease and inflammation, you have to have lower levels of pesticides and herbicides to have the high levels of antioxidants that you're looking for. So I think this is equally important. I think we need to reduce our risk by choosing those fruits and vegetables with the lowest residues or going organic whenever possible. And I think we have to get more out of our vegetables and fruits by choosing organic and those which are going to have less of an interference in a plant's natural ability to generate the most protective substances. Now, I've got 3 different areas here with which I want to offer you additional reading. I think it could be very, very helpful for those of you who might be hearing some of this for the first time or may really question because of some things you've heard previously. Many physicians and registered dietitians and nurse practitioners and different health professionals that I get the opportunity to meet with or speak to at conferences and webinars. Many health providers have heard this message that there's really no nutritional differences between organic and conventional fruits and vegetables. And I want to say that that's definitely not the case. That is only the case when researchers, and it's really important to look at study design, only look at things like minerals and trace minerals, which are going to solely be a function of what's in the soil. Once you start to qualitatively break down that research and you look at the important molecules in vegetables and fruits that are influenced by the way vegetable is either sprayed or not sprayed, then you start to appreciate that there are very significant differences between organic and conventional. So I want to make sure that's clear, and I have these papers for you to consider as additional reading. Then I want you to consider these 4 papers, and I really tried to put those more recent ones at the top here, a year or so old, 2 years old, looking at how glyphosate exposure alters neurological health in both children and adults. And then lastly, these 3, again, these are very recent papers. We're going 2020 to 2018. There are others, from 10 years ago, which clearly show a disruption in the gut microbiome with chronic glyphosate exposure. But these are 3 of the more recent ones that I think you'd find really eye-opening. And with that, I want to say it's always important for all of us to take a deep breath. Sometimes this can be really sobering, depressing research to look at. Certainly is something that I have to look at every day, and I have to find ways personally with which to stay positive. And I think the message here really should be a message of hope. We have good alternatives. We have good choices to make within the vegetable and fruit world. It's always a better choice to eat less grains and less cereals in today's world, not only to reduce our glyphosate exposure, but also to support a healthier microbiome. So we do have good choices, and we have those vegetables and fruits which if we have to buy conventional, are going to be part of that clean 15. So with that, I really want to thank you for your attention to this topic today. I know it's one that many of you might not get to listen to, and it's one that I'm always excited to talk about. So with that, again, I want to thank you, and I'd like to turn it over now, if I can, to Catherine. This ends my formal presentation. Thank you.
Thank you, John. So we will get to questions in just a moment. And John, if you can advance to the next slide. Okay, so for those of you who haven't joined us before, just a quick update that Functional Formularies has new peptide formulas, both a liquid HOPE peptide and a Nourish peptide. And on the next slide, you will see some of the benefits or some of the qualities that these 2 formulas have. Can you jump to the next one, John? So as with all Functional Formularies products, they are made from the highest quality ingredients, organic, plant-based. There is no added sugar, very low fructose, no syrups. And they are nutritionally complete and can be considered sole source nutrition. And on the next slide, you will see if you're interested in obtaining or trying these formulas for your patients, please feel free to email the team at sample@functionalformularies.com. There's also a new keto enteral formula. So if you're interested in samples, there's also a starter kit. The team will help you there, or if you have a local rep, please feel free to contact them as well. So with that, I will jump to some of the questions that we have rolling in here. There's a few questions, John, if you could speak to, can you wash vegetables and fruits to lower the level of chemicals, and is there any type of washing that you would recommend, such as with baking soda?
No, unfortunately, it's really disappointing that we don't have a simple treatment like that that would be effective. It's just not the case. It's important to understand that a lot of these pesticides and herbicides, they're applied throughout the growing season. Many are applied when a fruit first blossoms or is set as a blossom, and then everything applied to that, whether it be an apple blossom or a peach blossom, all of those pesticides basically become ingrown into the fruit. So they really have a pretty consistent concentration all the way from the pit through the flesh of a fruit or a vegetable. Now, again, there is some evidence that peeling vegetables and fruits can reduce that pesticide content, but here's the problem with that, is that's where most of the antioxidants are found. You know, whether it's the skin of a blueberry, which I know very well from my research, or it's the skin of an apple, or, you know, it's even the skin of carrots or beets. Most of the antioxidants, not all, but a high percentage, are found in the peel, or the outermost layer of these vegetables and fruits. So I don't recommend peeling those, because you're going to lose out on certain types of antioxidants and certain specific types of fermentable fiber. So that's really the only treatment, and it is not going to eliminate these pesticides completely. It might produce a 10 to 20% reduction, which is significant, but with that, you're going to lose a lot of antioxidants. So I don't really recommend washing, other than to maybe get rid of potential harmful bacteria, if that's a risk, depending on, you know, where it's grown. It's just really not going to have, you know, it's not an effective way to really treat fruits and vegetables, the peeling or the washing.
Okay, and for those of you asking for some of the references that John had on his slides, I will go ahead and create a reference document that I will send out. If not today, then in the next few days. So you will have a list of those references as well. Going back to the study from the beginning of the presentation, John, in JAMA on pregnancy loss and decreased risk with less pesticide residue exposure, do you know the amounts of exposure and the type of exposure that they were considering?
Yeah, they quantified exposure at 4 different levels, and it was largely determined, if you can, you know, again, we can make that particular slide and that paper certainly available to everybody. Those women that were in the study, what was used was a pesticide residue food frequency questionnaire. So they basically put high pesticide and herbicide fruits and vegetables in tiers, and they used averages, so average pesticide herbicide levels found in each of these groups, and then they looked at the frequency of those specific groups that were consumed over time. So it's very much like what many RDs are going to be familiar with from their coursework or the research they're involved with. It's a food frequency questionnaire where you place specific fruits and vegetables in groups based on their pesticide, average pesticide herbicide content, and then that is used to quantitatively give an exposure, if that helps.
Okay, and do you know if the EWG tests produce from large farms or growers only, or do they include small farms? Do they test all regions of the country?
Largely the testing is taken from large grocery stores and produce that is available on the shelf. So that's going to speak to this being, by and large, you know, major fruit and vegetable producers, not small farms.
Okay, and when you were speaking to glyphosate levels in the urine and that it is significantly higher in chronically ill individuals, who does that include?
Well, that includes all chronically ill patients, which would include, they found higher level, Monica Kruger's assessment, that toxicology report looked at those who had, you know, what we call metabolic syndrome, cardiovascular disease, cancer, insulin resistance. There was a very widespread range of chronic illness, but cancer was included in that. Again, I want to be really clear and unequivocally, I'm not saying that glyphosate causes cancer, but what has been shown is those populations who are chronically ill, whether you're looking at something that's more metabolic, cardiovascular disease, diabetes, as well as cancer, those populations all typically contain higher levels of glyphosate. So it included a very wide range of the chronically ill.
Okay, and do you know if glyphosate is used as an emulsifier in vaccines?
No, I do not. I would doubt that, but I don't know it.
Okay. Ideally, we would want levels to be as low as possible. Is there any acceptable or threshold daily intake of glyphosate for kids and adults that you've seen?
No, I'm sorry. I'm not aware of that, or I'm not aware that that has been established.
Since organic still uses more natural pesticides such as sulfur, is there research on these certain pesticides and on the microbiome as well?
There are a handful of papers which and these have been in places like the Journal of Agriculture and Food Chemistry. Some of these studies have been conducted at UC Davis, and they've looked at, whether it's garlic spray, sulfur, copper, all of which can be allowed under organic agricultural models because of they're actually, many of these things are needed by the plant and they have a place. There's a place for them physiologically within the plant. They have looked at those, and the only one that I've ever seen, and this is going to really speak to just specific crops, which would be peaches, nectarines, higher levels of copper, is the only organic allowed pesticide, if that's what we want to call copper, that has been shown to appear in higher levels in the blood, the urine, but none of the others have appeared in the research that I've looked at. So that's the only one that I would have as an example.
Okay. And this is a common question. So if a person is on a budget, is it better to avoid or consume conventional foods?
Well, I think the best thing for somebody on a limited budget is to use that Clean 15 list that we shared from the environmental working group, because that is an excellent way to purchase the cleanest vegetables and fruits without having to forego them. Often many of those fruits, like I'm going to use an example, a grapefruit. Grapefruits are exceptionally clean. Peas are very clean. You have excellent choices there within that Clean 15 set of foods, as well as some of the data that one could probably find by looking at the environmental working group's website, which are both very clean and affordable. So I in no way want to imply that people should avoid vegetables and fruit consumption. I think people should consume more vegetables than fruit, and that tends to work out really well for populations in terms of reducing your pesticide levels, because if you look, it's really clear that most of your heavy pesticide laden foods are things like strawberries and apples and peaches. So eating less fruit tends to work out very well. It doesn't mean people have to forego fruit. It's just maybe making a shift towards a more vegetable based diet as opposed to a more fruit based diet. And then again, using that Clean 15 guide, I think can be very helpful. But I wouldn't want people to avoid vegetables and fruit. I think it's important to eat them in large quantities, especially vegetables, and I would just choose those with the lower pesticide levels.
And for those asking about the environmental working group slides, as John mentioned, you can look up, that's available to you. Just search the environmental working group in the Dirty Dozen and Clean 15, and you'll have access to their most recent list. So we're nearing time. So this might be a question to near the end with, but regarding public policy, that feels like a key area of focus. Do you know, or what kinds of proposals and bills in Congress are out there in regards to holding these agribusinesses accountable and working to change the allowed use of pesticides and other agricultural practices that harm human health?
I mean, that's a very important, great question. I think there's several components to an answer to that. Number one is I want to say first that it's unfortunate, but it's a very slow process. Many of these chemicals are allowed to be used with very little evidence demonstrating long-term exposure and tolerance or health. That's a very important statement. So, a 2-week study with a large quantity of any given chemical looking for neoplasms or cancerous growths, that doesn't always capture the full effect or influence of any agrochemical on our health. So that's one of the biggest limitations right now that we're dealing with, is that chemicals are allowed to be used in production with an absence of long-term research or tolerance studies. Now, to answer the question, it's going to take a more grassroots concerted consumer effort, which is often what happens in Europe, and that's why many of these substances we've talked about are banned in Europe but allowed in the United States, that citizens in different countries, or now as part of the European Union, they have spoken out against, based on the research that has been made public, they have spoken out against many of these chemicals. They have written their local representatives, and they have started the same kind of process that basically we have the ability to do. Now, again, it's a slow process. It's not one that is as rapid as any of us would want, but we, the citizens here in the United States, really need to be who is guiding this process of what's allowed and what's not allowed. And if we don't do that, I think it's unrealistic to think that the EPA or the FDA is going to have the resources or the manpower to change what we all want changed. I think that's just the reality of it. So, number one, familiarizing people in your circles, whether you are a researcher or a clinician or a family member, familiarizing your circle of friends or peers with the research is step one. Number two is making a collective effort to take that research, which really condemns the use of many of these agrochemicals, to those representatives that are more local, and then again, they have to take it to the national level. But that's really the way we end up with banned substances. That's what happened with DDT, and that's really what it will take. At the same, again, it's a slow process, but that's what's going to be required with something like chlorpyrifos and glyphosate. The good news is things are starting to turn with glyphosate, albeit a different type of scenario, looking at exposure to glyphosate either through farm workers or those doing landscaping. The tide has started to turn with glyphosate, and I believe that it's going to eventually carry over to all levels of agriculture, and we're eventually going to end up with glyphosate being on a banned list. I think it's just going to take time. But that's the best answer I can provide, Catherine, in terms of a road to lower levels in our food.
Yeah, I think that was great. And we're at time. I think that's a great question to end on. As a reminder for anyone who got here late, the CE credit for registered dietitians is pending. So pending approval, that will be sent out, or you will receive an update on that. And for the references, a reference list will be sent to all attendees in the next few days. Thank you, John, for such a great, excellent presentation. Anything that you would like to share to end on?
No, thank you, Catherine. I appreciate it. And I just want to thank our listeners for their interest in this topic. Again, as I said earlier, it's really important. And I'd say it's most important for our children's health, because our children are being exposed to higher levels of these agrochemicals than ever before. But stay hopeful, stay positive. I think collectively we can make a change. So thank you very much.
All right. Thanks, John. And thank you, everyone. We will see you next time.